In question 4 we have a diagram of a gymnast trampolining. In travelling from her lowest position at A to her highest position at B, her centre of mass rises 4.2 meters vertically and she has a mass of 55 kilograms. In A we need to find the increase in her gravitational potential energy when ascending from position A to position B. Well, change in potential energy is equal to mass times gravitational field strength times change in height, which in this case is 55 kilograms, 9.81 newtons per kilogram, and a change in height of 4.2 meters, giving a change in potential energy of 2266 joules, or 2300 joules, to two significant figures. In B, she descends from position B, regaining contact with the trampoline in its unstretched position. Here her centre of mass is 3.2 meters below its position at B. In part 1 we need to find her kinetic energy at the instant she touches the unstretched trampoline. Well, for this the kinetic energy will equal the change in potential energy, which again is given by mass times gravitational field strength times change in height, but now with a change in height of 3.2 meters, giving 1727 joules, or 1700 joules, to two significant figures. In part 2 we need to find her vertical speed at this point. Well, kinetic energy is half mass times speed squared, so rearranging for speed and putting in the values gives a speed of 7.9 meters per second. In C we need to add an arrow to the diagram to show the force exerted on the gymnast by the trampoline when in position A. Well, the arrow showing the force of the trampoline on the gymnast should start at her feet and point upwards. In D, as she accelerates upwards again from position A, she is in contact with the trampoline for 0.26 seconds. We need to find the average acceleration she would experience while in contact with the trampoline if she is to reach the same height as before. Well, acceleration is change in speed over time, and she's going from stationary to 7.9 meters per second in 0.26 seconds, an acceleration of 30 meters per second squared. In E, on her next jump, she decides to reach a height above position B. We need to describe and explain in terms of energy and work the transformations that occur as she ascends from her lowest position A to her new position above B. Well, at her lowest position A, she has elastic potential energy stored in the trampoline. This will exert an upwards force on her, doing work to transfer the elastic potential energy to kinetic energy. As she rises, kinetic energy will be transferred to gravitational potential energy. To get higher than previously, she will have to do work pushing against the trampoline while in contact with it. She will do this by having her knees bent, straightening them while at position A. She will transfer chemical energy in her muscles to increase her kinetic energy on leaving the trampoline.